All right, so let's finish up this example and then do our last example with ideal gas law. So in the last video, we ended up with, we just converted our pressure to atmospheres. Remember, we always know R is 0.08206 liter atmosphere per Kelvin mole. And the temperature always has to be in Kelvin, and right now it's in Celsius, so 37 degrees Celsius. Add 273 to that, and you're going to get your Kelvin temperature is 310. We need to keep a decimal there because we get at least decimal places when you add, so this has no decimal places, so this has to go to the whole number. All right, so now we're going to solve for N. So N is equal to PV divided by RT. So we're going to plug in our pressure, 4.5 times 10 to the negative 4. Our volume, 2.2 liters, R, 0.08206, and the temperature, 310. And that's going to give us our moles. Remember, N stands for moles of air. And when you multiply that, we need to round it to two significant figures, so you end up getting 3.9 times 10 to the negative 5th moles of air. So this is one of our answers. But it wants us to figure out how many grams of air her lungs would contain. So we're going to now, without clearing your calculator out, we're going to convert 3.9 times 10 to the negative 5 moles to grams. Now, they gave us the molar mass of air here because air is a mixture. It's not just one gas. It's a mixture of gases. They told us it's 29 grams per mole. So we're going to use that. It's going to multiply by 29 grams per mole. Let's moles cancel out. And you get your final answer. I'm going to put it in scientific notation, 1.1 times 10 to the negative 3 grams. Now, if you want to leave that in standard form, that is perfectly fine. Just don't forget leading zeros are not counted as sig figs. So if you leave it in standard form, 0.0011 grams. Okay, our last example. This one was the molar. Remember, the units for molar mass are grams per mole. So if you get stuck on doing any of these problems, look back in your notes where we talked about each little strategy, because this is one that gives students trouble typically. All right, they're giving us the mass of the gas. We're going to use that at the end when we get the molar mass, okay? So it says you got 35.44 grams of a gas stored in 7.50 liter tank, exerting a pressure of 60 atmospheres at a constant temperature of 35.5 degrees Celsius. It wants us to find the molar mass, so we're going to use Pivner to do that. Again, R is always our constant, 0.08206. The temperature, 35.5 degrees Celsius. Now, when you add your 273, remember that's unlimited sig figs, y'all. So we're going to go with least decimal places, which technically is one decimal place here when you add. So your temperature is 308.5 Kelvin. You need one decimal place here because this has the least decimal places. We're going to end up finding our moles, and then we're of course going to, once we find our moles, we're going to go to molecular weight. We're going to find the molar mass of the gas. The pressure is 60, and it's in atmospheres, and it has one sig fig because there's no decimal there. And then the volume is 7.50 liters, and that is the proper unit here. So all of our units are correct for this gas law. So now we're going to plug it in, and we're going to find moles first. PV divided by RT. So when you plug in 60 for your pressure, 7.50 for your volume, 0.08206 for your R, 308.5 for your temperature. That's going to help you get to your moles of your gas. You need one sig fig. So when I rounded this to one sig fig, my calculator gives me like 17.775. But you round it to one sig fig, so you would round that to 20 moles. So here's 20 moles. But remember, do not clear your calculator out. We're going to use this now to help us get molar mass. Recall, molar mass is the number of grams of the substance divided by the number of moles of the substance. Well, guys, we just found the moles, so that's going to go in the denominator. The grams were given in the beginning of the problem, 35.44 grams. You see, we need our units to be grams divided by moles. And so you're going to make that happen by taking the grams, 35.44 grams, and you're going to now divide it by this number you got. Now, I have not cleared my calculator out. I still have this 17.775 number in my calculator. So I'm just going to say 35.44 divided by, and on your calculator, you go second answer, and that'll pull this whole number in. But on my paper, I'm going to write 20 moles because that's what we rounded it to for moles. You need one sig fig in your answer. Notice nothing divides out, so your units, as far as your units go, so your unit's going to carry down grams per mole, and we're going to round this molar mass to only one sig fig. So that's going to give you a final molar mass of 2 grams per mole. So more than likely this gas is just hydrogen gas. Remember, hydrogen gas is 2.02. If you just look at his formula, grams per mole. You were not asked to identify the gas here. I'm just kind of saying that's probably hydrogen gas. Okay, that's it for our gas law examples for ideal gas law. Now you should be able to work through the problems on your homework. Thanks so much.